Bismillahirrahmanirrahim. Today we'll discuss the reference input uh, addition. But before that, yesterday I discussed that in the state feedback control, where we analyze the uh, total number of poles and of the closed loop system and the separation principle, and we discussed that rather than evaluating the dynamics of x dot and x hat dot, it is equally well that you evaluate the dynamics of uh, x dot and e dot, and dynamics will not change, mean the eigenvalues of uh, this system, which is the system originally visible from the Simulink diagram. These are the states which are visible from the Simulink diagram, and this is the picture from the last lecture, 11A. Yeah. And these are the two state variables for which differentials are visible in this Simulink diagram. So rather than evaluating the dynamics of this and the dynamic, we can discuss the dynamics of this x dot and e dot, and the eigenvalues of this system are the same as the eigenvalues of this system. So I yesterday gave you the transformation matrix, but just quickly go over in the just go over the transformation from this to this, means from this system to the original visible system, original visible states on the Simulink diagram. And I told you that the transformation matrix is I0, I minus I. This is the transformation matrix, right? So just quickly, let's quickly go over the state transformation, which we already did in the control system one, but it's gonna take only a minute. So let's do it again. So suppose this is the original x dot is equal to ax plus bu original system. Then suppose the new states are x hat is equal to tx. And that's how we select x bar. X bar is equal to tx. And we x bar are the new state, x are the original state, t is the transformation matrix, and t is the transformation matrix if we want to go from this state to this state. And t is I0, I minus I, and if I multiply this with x dot and e dot, it will give me x dot and x dot minus e dot, and it will give me the states x dot and x hat dot, which are the visible states. So this is the transformation matrix. And how to do the transformation? Let's calculate, replace x in the original system by x bar. So x is equal to, from here I can conclude that x is equal to t inverse x bar, and replace the x over here in this. So it will be t inverse x bar dot. Obviously you can take the dots over here, and derivative on both sides, this is constant, so there is no derivative for this. So x dot, let's put the derivative with this, x dot and x bar dot. So so replace the x and x dot with x bar and x bar dot. So this is t inverse x bar dot is equal to a, and x is replaced by t inverse x bar. So t inverse x bar plus bu, and now I can calculate x bar dot is equal to, multiply right side with both sides with t. So t inverse will cancel over here, and it will be t a t inverse x bar plus TBU. And if we analyze the original system, if we analyze this system, we calculated in the last lecture that uh, in the last lecture that this is the matrix A minus BK 0, A minus LC. So now let's convert this system to this system. So all I need to do is just uh, x bar dot and x bar dot is equal to T and A of the this system is this one, A minus BK